Hello, in this video, we're going to be solving question 46 of the 2021 Junior Mathematics Olympiad first round. So we're asked to find how many consecutive zeros will occur on the right-hand end of 20 factorial. So 20 factorial is just shorthand for 1 times 2 times 3 times 4 all the way so we're asked to find how many zeros we'll have at the end of the number we'll get if we multiply all the numbers from 1 all the way to 20. Before we talk about this, let's digress a bit to something that is important to know to be able to solve this question. So this is, why do we have zeros at the end of numbers? So let's look at 60, for example. Why does 60 have 1 0 at the end of it? So if you write out the prime factorization of 60, that would be 2 raised to the power 2 times 3 times 5. The reason why 60 has 1 0 at the end is because a 2 in its prime factorization multiplies by a 5 to give us 10. So that's the reason why we have 1 0 at the end. If you look at 200 instead, the prime factorization of 200 is 2 cubed times 25. We can write 25 as 5 squared. So we'll write it as 2 cubed times 5 squared. So the reason why 200 has 2 zeros at the end is because 2 2's here and 2 5's here multiplied each other in pairs. So the first 2 and 2 multiplied each other to give 10, and the other 2 and 2 multiplied each other to give 10. And those two 10's now become zeros at the end of the products that we have. So the point I'm making here is that if you put the power of 5 in the prime factorization of a number, and not the power of 2 in the prime factorization of a number, then you can tell how many zeros that number will have on the right-hand end of it. So if, for example, you know that a number has the power of 5 in a number is 5 raised to the power 4, and the power of 2 in the number is 2 raised to the power, let's say, 3, right? Since this number has 4 5's and 2 3's, and when 5 and 2 multiply each other in pairs, we have 10's, right? So 5 of these 3's here, that's 5 raised to the power 3. Sorry, 3 of these 5's will multiply by 3 of these 2's to give us 10, to give us 3 10's. So if you multiply a number that's the power of 5 in it is 4 and the power of 2 in it is 3, that number is going to have 3 zeros at the end of it, because 3 5's and 2 3's and 3 2's here are going to pair up with each other to give us 10, to give us 3 10's. So that's just the idea that we're going to be working with and solving this question. So the next thing we're going to talk about is so now we're going to ask ourselves now, how many 2's, what's the power of 2 in the prime factorization of 20 factorial? And there's a general expression to find that. So the power of 2, the power of a prime p in the product, in the number n, in the product, so the power of p, the power of p in the product n factorial is the floor function of n over p plus the floor function of n over p squared plus the floor function of n over p cubed plus the floor function of n over p raised to the power 4, and then you just keep on adding the floor function of p raised to the power 5, floor function of p raised to the power 6, and so on up till infinity. So this is the formula to get the power of a prime p in the product n factorial. And so the power of 2 in the product 20 factorial now will be, let me write that here, the power of 2 in 20 factorial is going to be the floor function of 20 over 4 plus the floor function of 20 over 8 plus the floor function of 20 over 16 plus the floor function of 20 over 32 plus floor function of 20 over 64, and so on up till infinity. Let me just talk about what the floor function is in case anyone is not familiar with it. So the floor function of a number written like this, floor function of x, is the integer part of sorry, is the whole number part of x, right? So the floor function of 3.2 is 3 because the whole number part of 3.2 is 3. The floor function of 6.8 is 6 because the whole number part of 6.8 is 6. The floor function of 7.2 is 7 because the whole number part of 7.2 is 7. And for whole numbers is similar. So floor function of 9 is 9 because the whole number part of 9 is 9. Floor function of 10 is 10 because the whole number part of 10 is 10. For negative numbers, the floor function works a bit differently, but for positive numbers, looking at it as the whole number part of a number is enough to make sense out of it, right? Okay, so now back to the question, back to the expression we have down here. We are looking for the power of 2 in 20 factorial. Notice that from here onwards, we're going to have 0. Okay, so the floor function of 20 over 2 is the floor function of 10, which is just 10. The floor function of 20 over 4 is, so 20 over 4 is 4, sorry, is 5, right? So that will just be 5. Yes. The floor function of 20 over 8 now. So 20 over 8 is 2 point something, right? So 2 is the whole number part of it. So that will be 2. And then 20 over 16 is 1 point something. So the whole number part of it is 1. And the floor function of 20 over 16 will be 1. But then from 20 over 32 onwards, notice that the number you'll be having there will be 0 point something. So 20 over 32 may be something like 0.6 something. So the whole number part there will be 0. So the whole number part in this here will be 0. The whole number part here will be 0. And if you continue like that with 128, the whole number part will still be 0, right? So we'll just have zeros for the rest of the terms that we'll have. So that means that the power of 2 in 20 factorial is 10 plus 5 plus 2 plus 1, which is 18. So if you write out the prime factorization of 20 factorial, the power of 2 you're going to have will be 2 raised to the power 18. So we have this aside. We'll just box that here. Okay, so now we're going to look at the power of 5 now in 20 factorial. Okay, so using a similar idea to the way we did the first part, the power of 5 in 20 factorial is going to be the floor function of 20 divided by 5 plus the floor function of 20 divided by 5 squared plus the floor function of 20 divided by 5 cubed and so on. Okay, so we have 20 over 5 here. So 20 over 5 is 4. So floor function of 20 over 5 will be 4. But then 20 over 5 squared is 20 over 25, which is 0 point something. So the whole number part of 20 over 5 squared is 0. So this expression here, this floor function here, will be 0. And the next one too will be 20 over 125, which is 0 point something. So the whole number part of it will be 0. And every number after this too. So 20 over 625 will be 0 point something still. And the whole number part will be 0. So every number beyond this point here, the floor function of it is going to be 0. So from this, we can just conclude that the power of 5 in 20 factorial will be 4. Right? Yes. So now we know that if we write out the prime factorization of 20 factorial, we're going to have 5 raised to the power 4 in it. So now notice that in 20 factorial, we'll have 18 twos. That's in the prime factorization of 20 factorial. We'll have 18 twos and 5 fours. So let me just write down here. So we have 18 twos and 5 fours. And remember from what I described up here, you have a 0 at the end of a number when a 2 and a 4 multiply each other to give you a 10. So since we have 18 twos and 5 fours, the highest number of twos and fours we can have will be, and multiplying each other will be 5 twos. So we're going to have 5 twos and 5 fours multiplying each other. Sorry, we're going to have 5 twos and 4 fives multiplying each other, right? So 5 twos and 4 fives multiplying each other. Sorry, it's not going to be 5 twos, it's going to be 4 twos and 4 fives multiplying each other. And when they multiply each other, we'll have 10 raised to the power 4 at the end. So since we're going to have 4 twos and 4 fives multiplying each other in the prime factorization of 20 factorial, we can conclude that this number is going to have 4 zeros at the end of it. So that's how to go about solving this question on the exam. So just as I described earlier for 60, the reason why 60 has just one zero is because just a pair of 2 and 5 multiply each other in their prime factorization. The reason why 200 has two zeros is because two pairs of 2 and 5 multiply each other in their prime factorization. That's two twos from here and two fives from here. And in our question, we have 18 twos and 4 fives. Right, so since we have 18 twos and 4 fives, twos and 4 of the fives will multiply each other to give us 4 pairs of tens. That's going to, so those 4 pairs of tens are going to result in 4 zeros at the end of 20 factorial. So the correct answer to this question that we're solving is A. So that's how to go about solving this question. Yeah.